In this video, we are going to answer two questions on integration. So mixed exercise 11.01 is on integration for A-level Pure Maths Year 2. Question 1. Find the integral of cos squared half x dx. B. Evaluate the definite integral of a to the power 4 over x cubed plus x to the power 3 over x squared with respect to x and between the limits a and 2a. So for a, we need to integrate cos squared half x dx. Before we can do that, we need to change this to a form that will enable us to integrate easily. So we need to use trig identities to change this to a form that we can easily integrate. And the trig identity we are going to use is cos 2x is equals to 2 cos squared x minus 1. I want you to pay particular attention to this angle and this angle. Please note that this is 2x and this is half of this, and therefore that's x. We can use a similar identity involving half x as follows. Cos x is equal to 2 cos squared half x minus 1. Note again that this is half of this one, just like the one we wrote before. All we do now is rearrange this and make cos squared half x the subject. And so we can write cos x plus 1 is equal to 2 cos squared half x. Then cos squared half x becomes half brackets cos x plus 1. We can now replace cos squared half x with half brackets cos x plus 1. And so we have integral of half cos x plus 1 dx. I can bring the half out to get half the integral of cos x plus 1 dx. And now, as you can see, we can easily integrate cos x and also 1. When we integrate, we are going to get half brackets sine x plus x, and then we can add our integration constant. If you want, you can expand this to get half sine x plus half x plus c. And this is the final answer for question 1a. For b, the definite integral to evaluate is the integral of a to the power 4 over x cubed plus x cubed over a squared dx between the limits of a and 2a. We need to first of all write this in a convenient form as follows. The integral of a to the power 4 times x to the power minus 3 plus 1 over a squared times x to the power 3 dx between the limits again of a and 2a. If I integrate it, I'm going to get a to the power 4 over minus 2 times x raised to the power minus 2, because I need to add 1 to this power here, and if I do that, I get minus 2, and then divide the coefficient by minus 2. I'll do the same thing for the second term, and I'm going to get plus 1 over 4 a squared times x to the power 4. Again, between the limits a and 2a. I will then write this in a convenient form to facilitate the evaluation, and that will be a to the power 4 over minus 2x squared plus 1 over 4a squared times x to the power 4 between the required limits of a and 2a. I'm now going to substitute 2a into this expression and also a into the same expression and subtract them as follows. So I'm going to get a to the power 4 over minus 2 brackets 2a, all of that squared, plus 2a all to the power 4 over 4a squared minus a to the power 4 over minus 2a squared plus a to the power 4 over 4a squared. Then I'm going to expand these brackets and simplify each of the terms. For this first term, I'm going to get minus a to the power 4 over 8a squared, because 2 squared is 4 and 4 times 2 is 8. But the whole thing is negative, and that's why I put a negative sign here. If I do the same thing for that, I'm going to get 2 to the power 4, that's 16, and that would be 16a to the power 4. So I'll get 16 a to the power 4 over 4a squared. And then I'll expand these brackets. A negative times a negative gives you positive. So I'm going to get plus a to the power 4 over 2a squared. And then a negative times a positive gives me a negative. That will give minus a to the power 4 over 4a squared. Then I can see that I've got a to the power 4 here and a to the power 2. So that can be simplified to get a to the power 2. And so the whole of this expression becomes minus 1/8a squared. And so I'm going to get minus 1/8a squared. And for this one, 4 goes here 1 and 4 goes there 4. And this will cancel 2 of these to give you a squared here. And that means I'm left with plus 4a squared. In the same way, this will reduce to plus half a squared, and then the last term will be 1/4 a squared. Now I have 4a squared plus half a squared, and that will give 9 over 2a squared, and then minus 1/8 a squared minus 1/4 a squared will give minus 3 over 8 a squared. 9 over 2a squared minus 3 over 8a squared, when evaluated, will give 33 over 8a squared. And that is the required definite integral for question 1b. Question 2. Find the integration of x sine x dx. That's for A. And for B, find the integral of ln x dx. So for A, looking at this, the only way you can integrate this is using integration by parts. So we need to remember the formula for integration by parts, which is given by integral of u dv is equals to u v minus the integral of v du. And so we are going to let u be equal to x, and that means dv equals to sine x dx. When we differentiate u with respect to x, we are going to get du is equals to 1 dx. And if we integrate sine x with respect to x, we're going to get v. So the integral of sine x dx, which will give us minus cos x. So we are now going to replace u with x and dv with sine x dx, which becomes the integration we are looking for. And so the integral of x sine x dx will be equals to u, which is x, and v, which is minus cos x, and we get minus x cos x. Then minus the integral of v du. Well, we know that v is minus cos x and du is dx. So we're going to get minus cos x dx. We can rewrite this to get minus x cos x plus integral of cos x dx. We can easily integrate cos x, which is sine x. So now our integration becomes minus x cos x plus sine x and we add our integration constant. If you want, we can rewrite this as sine x minus x cos x plus c. And that is our answer. For b, we're going to integrate ln x dx. But we have to rewrite this as follows. Integral of 1 times ln x dx. We can then use the formula for integration by parts, which is given by the integration of u dv is equals to uv minus integration of v du. So we will let, in this case, u to be equals to ln x, because we can differentiate that easily. And so dv will be equals to 1 dx. If I differentiate du with respect to x, I'll get du is equals to 1 over x dx. And if I find v, I'm going to do v is equals to the integral of 1 dx, and that will give me x. So v equals to x. We can now go and do our substitution. U dv, same as ln x times 1. And so we have integral of ln x dx equals to u v, that would be x times ln x, x ln x minus the integral of v, which is x, times du, which is 1 over x dx. So times 1 over x dx. Well, you can see that this will cancel that. I'm left with 1 dx, which is the same as dx. And so we have x ln x minus the integral of dx. And if we integrate dx, we are going to get x. And so we have x ln x minus x. And then we add our integration constant. And that's the integration of ln x. And this is the final answer. And this brings us to the end of this set of questions on integration for mixed exercise 1.01. Thank you again for watching, and I'll see you in the next video.